Hi, this is Ms. Fitzmaurice, and this video is an explanation of the problem on pages 11 and 12 of your Unit 2 packet. So, in this problem, we have an airplane, and it is flying with a velocity of 240 meters per second and an angle of 30 degrees with the horizontal. Okay, it says that when the altitude of the plane is 2.4 kilometers, a flare is released, and the flare hits the target on the ground. First of all, we want to know the vertical, so that's the up and down component of the flare's velocity just as it is released. So the instant it's released has the same velocity as the plane, okay, which we know is 240 meters per second. And we know that it is at an angle of 30 degrees with the horizontal. So if we want the vertical component, that's this side, we know that Vy will just be our total velocity times sine 30. So that's 240 times sine 30, which is equal to 120 meters per second. But I'm going to put a negative there because I know it's heading downwards. Now I have to do the same thing for the horizontal component. Okay, so Vy, or Vx, is this side of the triangle. Okay, and I know that Vx will be V times cosine 30, which will be 240 times root 3 over 2, which is about 120 times the square root of 3 meters per second. I could find a decimal, but that's not too important. Alright, in part C, the problem asks us to calculate the time that elapses from when the flare is released until it hits the target. So to do this, I'm going to need a little bit more space. Alright, but I can make an XY chart. I have XOX, we can set that equal to 0, XX, we'll see what that ends up being. VOX, we found out, was 120 times the square root of 3. VX, we don't know, but AX will be 0, and so VX will stay the same the whole time. Now, XOY is the initial height, which we know from the problem is 240 or 2.4 kilometers, so that's 2,400 meters. XY, when it hits the target, it's on the ground, so its final height is 0. VOY, we found out, was minus 120 meters per second. Vy, we don't know, but we do know that AY is equal to negative 10. Now, looking at these two sides, I see that I have more information in the y direction, and because of that, what I can do is I can use that to solve for time. And looking at my kinematics equations, I realize that I have to go with the first equation. So I have xy equals xoy plus voyt plus 1/2 ayt squared. Okay, xy we know is 0, xoy is 2,400. Okay, and then we have minus 120t plus 1/2 times negative 10 t squared. And so I have 0 equals 2400 minus 120t minus 5t squared. Okay, to solve this, I'm going to have to use the Pythagorean Theorem. Okay, and so in math, the thing next to your x squared you call a, the thing next to x you usually call b, and the last thing you call c. We can do the same thing here. And so we have t is equal to negative b, so that is positive 120, plus or minus the square root of 120 squared minus 4 times negative 5 times c, which is 2400. And I'm going to divide that all by 2 times negative 5. And I get two answers. I get t is equal to minus 3.7 seconds, and I also get t equals 12.9 seconds. And this is the one that makes actual physical sense. Alright, so D asks us, a person standing at the target has to look up and to the left to see when the plane releases the flare. We want to know the angle above the ground. Okay, so we already know that, so here's the person at the target. We already know that the plane releases it from a height of 2,400 meters. And if we knew just one more side of this triangle, we would be able to find this angle. Okay, we can use the x information to find xx, and then we can use inverse tangent. So we're going to go ahead and use the fact that t is equal to 1.3 seconds, or sorry, 13, not 1.3, but 13 seconds, and I'm rounding a little bit, but that's okay. And we can solve for xx with the first equation. Xx equals xox plus voxt plus 1/2 axt squared. Okay, we know that ax and xox are 0, and we have xx equals vox, which was 120 times square root of 3 times t, which was 13, and we get 2698 meters. Okay, so now I want to calculate this angle. All I have to do is use SOHCAHTOA, so I have 2698. Okay, and I know that tan theta equals 2400 divided by 2698. I use inverse tangent, so theta is going to be tan to the minus 1 of 2400 over 2698, and I end up with theta is about 41.6 degrees. Alright, in part D we want the magnitude and direction of the flare's velocity just as it collides with the target. So magnitude means size, and if we have something that is pointing in a given direction, we need to find the hypotenuse. So magnitude really means hypotenuse. Alright, so we need to know, to find the magnitude or the hypotenuse of our velocity, we need to know what is Vy and what is Vx. And then we can use the Pythagorean Theorem. Alright, so we know Vx is going to stay the same, and we know that that is already 120 times the square root of 3. Vy, on the other hand, is going to change because of acceleration. Okay, so let's ignore part F for right now. We know that Vy is equal to Voy plus Ay times t. Okay, we know t is 13 seconds. We know Voy is minus 120. And so we can plug that in to find Vy. Okay, so we have Vy equals minus 120 plus negative 10 times 13. And we can see that Vy is really minus 250 meters per second. Okay, so now we have Vx, we have Vy, and we can find the total. Okay, we can use the Pythagorean Theorem, and we'll end up with the square root of 250 squared plus 120 root 3 squared, and we end up with a hypotenuse, or a total of 325 meters per second. Now I can also use that to find the angle, so I'm separating just for clarification. Part E from part D. And if I want to find the angle, I can use inverse tan of Vy over Vx over Vy. Okay, so our angle will be inverse tan of 250 over 120 times the square root of 3, and we end up with an angle of 50.2 degrees. Alright, so F just asks us to compare D and E, and the angle is different. Okay, and the reason is that there's acceleration in the y direction.